Good morning, everyone, and welcome to the April Pacific Northwest DEWS Drought and Climate Outlook webinar. Thanks for joining us. My name is Megan Dalton, and I'm with the Pacific Northwest Research Consortium, or CIRC. This is a bi-monthly webinar series hosted by NIDIS and CIRC and the Northwest Climate Hub. It is designed to provide stakeholders in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, and also includes discussions of observed impacts and other relevant updates from across the region. This webinar is being recorded, and the recording will be posted on drought.gov later this week. Just as a note, after today's webinar, you will have the opportunity to provide feedback, and that will help us improve the webinar series, so please take a moment and tell us what you think. Today's speakers include Nick Bond, the Washington State climatologist, who will present the climate recap and current conditions. And then Robin Fox with the National Weather Service Spokane Weather Forecast Office will present the climate outlook. And then next we have Oriana Chegwin, who is a CIRC graduate student at the University of Washington, and she'll demonstrate how to use the forecast tools in the climate toolbox. And finally, Kelly Smith with the National Drought Mitigation Center will demonstrate how to use the new drought condition monitoring observer reporting system. So during the presentations, please feel free to use the chat box to ask questions, or the question box. You can ask questions during the presentations, and if we have time, we can take those questions at the end of the speaker. If not, we will address all questions at the end of all speakers. And before we move into the presentations, we'll briefly highlight the partners that make this webinar series happen. So first, the Pacific Northwest Climate Impacts Research Consortium, or CIRC, is a climate science to climate action team funded by NOAA's Regional Integrated Sciences and Assessment Program. CIRC supports communities, policymakers, and resource managers in Oregon, Washington, Idaho, and Western Montana as they work to adapt to changing climate by transforming the latest climate science and data into usable knowledge. Secondly, the Northwest Climate Hub develops and delivers science-based region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making. And finally, to highlight NIDIS, I'll turn it over to Britt Parker, the Pacific Northwest DEWS coordinator.
Thank you, Megan. NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risks. We do this by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We want to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of early warning information for drought risk management. NIDIS's approach to achieve this goal is to build the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that can help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their regions. The Pacific Northwest DEWS was officially launched in February of 2016, and our strategic plan is available on drought.gov. And please note, we've updated this plan, and the new version will be released and available soon. So please mark your calendars for our next webinar, which will be on June 22nd of 2020. And also, I wanted to flag that the next water supply forecast monthly briefing from the Northwest River Forecast Center will be held on May 7th. These monthly water supply briefings are held January through late spring on the first Thursday of each month, and you can register by looking at the entry on May 7 of the drought.gov calendar, or you can Google the Northwest River Forecast Center water supply forecast briefing. Finally, I wanted to flag that the Commission for Environmental Cooperation of North America, or CEC, is requesting your participation in a survey to help them understand which indicators and indices are most useful for monitoring drought in North America. This information will improve the ability for regional and local decision makers to monitor and prepare for drought conditions, and will inform the development of a set of guidelines for use of locally relevant indicators in North American climate regions. If you would like to participate, there will be a link in your post-webinar email. Finally, to facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCOROS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition monitoring. Observations by COCOROS observers of precipitation events or the lack of precipitation are important to capture and improve our understanding of weather. And this is the way to contact your state coordinator, and I'll leave that up as we switch to our presenters today. Thank you.
All right, thanks, Britt. So we'll start it off today with the climate recap with Nick Bond.
And thank you.
Yep, and Nick, it should be coming your way.
Okay, all right, thank you. And thanks everybody who's joined this webinar. I've been promised 10% of the door, and so, you know, that's great. I was starting off with this photo that was from published last week by the Washington Ag Network. There was no photo credit, so I don't know exactly where this is from, but presumably it's from last week, and it does show pretty dry conditions around. Okay, but let's take a larger perspective and take a peek at what the U.S. Drought Monitor is showing as of last week. And you can see that there's much of the Northwest is actually in drought, and there's actually a little bullseye in extreme northwestern California, southwestern Oregon, and extreme drought of D3. How did we get here? Well, it's actually gotten a fair amount worse in parts of the Northwest over the last couple of months. And in particular, there's been some degradation in conditions, both in a small region in eastern Washington, east of the Cascades, but especially in western Oregon. All right. So let's take a peek at just what the weather that's been associated with that. Here, what I've plotted in the on the left is the temperature anomalies for the last 60 days up until last week. So it's a little out of date. I'm a little out of date, so you know it's all in keeping. But so temperature anomalies on the left, precipitation anomalies in terms of percent on the right. And I can see there was some warm spots and cold spots in the Northwest, but definitely dry overall, and especially there in that kind of hot spot in southwestern Oregon and east of the Cascades of Washington. Looking a little bit more recently, it's kind of the same sort of idea there. One thing that has happened in the last month or so is some quite chilly weather, especially in Montana, that has been kind of getting a lot of cold Canadian air during that period. I highlight in the map at the right, OMAC, kind of the poster child of one of the problems in Washington State. And if we look at the time series since the last week of February for the precipitation at that spot, can see why there's some real concerns in that it's as of the 23rd of April, it only had 0.15 inches of precipitation. It got a tenth or two since then, but that's much different than in 2017, 2018, when the problem was too much water and flooding and so forth. All right. In terms of the snowpack, we're actually in pretty good shape in most spots, especially at the higher elevations. This is kind of a busy figure showing just for all the snowtail sites, the percentage normal as of late last week. And in particular, the higher elevations are doing pretty well. And the Canadian part of the Columbia River watershed is doing reasonably well. And so there's a theme here is that the larger river, the Snake and the Columbia, we think are going to be in pretty good shape. Medium ones, you know, probably okay. Some of the smaller rain-fed ones could be a different story. And just to kind of reinforce that, here are one of these teacup diagrams that I trust a lot of you have seen, just what the reservoirs storage is like. Here in the Yakima Basin, not too bad. A little bit below normal, but ahead of last year, as shown in the kind of time series graph on the right. And so we don't anticipate real water shortages for the Yakima Basin. Two other places are highlighted in this slide, and in particular on the left is the parts of the Rogue River Basin, Southwest Oregon, that shows a lot of those reservoirs are definitely not close to capacity. But for the Snake, on the other hand, on the right, looking good there. All right, stream flows themselves, again, kind of a mixed bag. You don't see a lot of the light blue or bright blue dots there showing above normal stream flows. That's in part because, you know, pretty cool weather. We're not getting a really rapid snow melt, at least yet. There are some streams that are definitely showing much below normal stream flows for this time of year, and that is, again, a consequence of the very dry April we've had. This plot is shows soil moisture as of from the Climate Prediction Center of NOAA, and in a percentile form. And note the really low values east of the Cascades and in Western Oregon here. Different analyses are showing different things, and one thing that I haven't quite figured out is there's an experimental water kind of monitoring system at UCLA that is showing much higher values for soil moisture. And so I'm not sure what's going on, but I know it's been dry in the places where it's shown low values here. And so I think, again, while the upper elevation snowpack is in pretty good shape, the lack of precipitation means that lower elevations in much of the Northwest, it's on the dry side. How did we get here? There's been a big ridge of higher than normal pressure, higher heights aloft to our west, northwesterly flow anomalies that have brought some precipitation to the western part of Washington. But this kind of flow configuration is not really good for the east side. And as you might imagine, you can understand why it would have brought relatively chilly weather into Idaho and western Montana. One last thing, many of you know my proclivities here that, you know, keeping track of the ocean and all that, that it is warm out there, and it conceivably will have a future impact on our weather. And I'll be very interested to hear, you know, what Robin's going to be talking about in just a minute. So to just recap, last 2 months been dry and mostly on the cool side in the Pacific Northwest. High elevation snowpack in good shape. Soil moisture contents are low. The landscape is drying out. There's some concerns from various users cropping up there. And as a result, drought conditions have worsened in much of the states of Oregon and Washington. And with that, I'll close.
All right, thank you, Nick. Okay, next we'll move on to Robin Fox for the Climate Outlook.
All right, hello everybody, and hopefully you can see my screen in the present mode.
Yes, we can.
My name is Robin Fox. I am a meteorologist and hydrofocal point at the Weather Service office in Spokane, Washington. So Eastern Washington, where the drought is growing. So we're going to take a little bit more look at the outlooks and seasonal conditions. So here is the latest Climate Prediction Center's weekly presentation was released this morning. And so neutral conditions are present. The equatorial sea surface temperatures are above average across much of the Pacific Ocean, and the tropical atmospheric circulation is consistent with the ENSO neutral conditions. So it is warm in the sea surface temperatures. The oceanic Niño index has been consistently higher than above 0 for the last 8 months, placing it still within the neutral zone of that 0.5 to minus 0.5 range. And there hasn't been any significant changes throughout the winter, as you can see by what we've seen the last 8 months. The sea surface temperatures remain positive across much of the Pacific equatorial region, like Nick pointed out, especially in the East Central Pacific. And the subsurface temperature anomalies increased last fall and remain high through February of 2020. But during March, these positive anomalies have weakened and now are trending negative. So taking a look at the climate models, the CPC International Research Institute models favor ENSO neutral conditions to continue through the spring and summer of 2020 and possibly persisting through the autumn. The probabilistic forecasts do show a decrease in probability through the year, as seen by the model spread on the right. But for the next several months, there is good confidence that ENSO neutral conditions will continue. So what does this mean for our weather pattern as we enter into summer? Here is another climate model, the North American Multi-Model Ensemble Project, and it trends on temperature and precipitation for May through July. And it does show a strong signal of warmer than normal temperatures. For precipitation, it does trend drier than normal, especially for the western sections of Washington and Oregon. What it does reinforce is our current atmospheric pattern that has been controlled by that strong ridge of high pressure in the eastern Pacific and the northwest flow into the northern Rockies and central US. Another feature to keep in mind is the Arctic Oscillation, which has been trending positive for the last several months. It is projected to continue mostly positive. This, coupled with an ENSO neutral outlook, has an impact on the atmospheric pattern into early summer. In the precipitation anomalies, drier trends are noted. Going from an ENSO neutral winter into an ENSO neutral summer, we can look back at past seasons and see when this happened before. And we have identified several years, with most recently back in 2013 and 2014. And we can examine the composites of temperatures and precipitation anomalies from these years. And here are the charts for May through July that shows these past seasons, showing above normal temperatures, especially for Washington, and just slight changes seen in precipitation. So let's take a look at the outlooks. Here is the Climate Prediction Center's 8 to 14-day outlook that spans into early May, and it shows better chances for warmer than normal temperatures on the west side down into Oregon, and near to slightly below temperatures in eastern Washington into North Idaho. Precipitation patterns remain progressive with near to slightly above normal precipitation. Here's a quick look at the experimental 3 to 4 week outlook for late May, and it shows a better chance of above normal temperatures expanding across western Washington and Oregon, while a better chance of below normal precipitation expands across eastern Oregon. And this does seem to coordinate well with the 1-month outlook for the month of May that indicates above normal temperatures across much of the Pacific Northwest and a drier trend for Western Washington and Western Oregon. Now, as we jump ahead to the 3-month outlook for May through July, the warmer and drier trend expands across the region with better chances of above normal temperatures and below normal precipitation. So what are the impacts of warmer and drier conditions expanding across the Pacific Northwest? Well, one is the current drought conditions and how they will likely remain and expand across the region. Here's a comparison of the monthly drought outlook compared to the seasonal drought outlook. You can see central Washington and much of Oregon expanding as we go through the next couple months. Another impact will be the wildfire season. Currently, fuels are greening up, especially across eastern Washington and North Idaho, and will continue into June, where wildland fire potential looks normal for springtime. Although as we move into July, the fire potential is expected to increase region-wide with drier fuels. And then there is the water supply, as Nick pointed out. Current mountain snowpack looks solid across much of Washington, North Idaho, and parts of northern Oregon, thanks to an active winter and a cool early spring. Although deficiencies are seen across southern Oregon. The snowpack has a good relationship on the water supply into the summer months. And many of the mainstream rivers in Washington and North Idaho and northern Oregon will see good flows, while below normal flows are possible across parts of southern Oregon and southern Idaho. Some of these smaller streams may see lower flows as well as this drier trend continues. One thing I do want to point out is with the warmer temperatures coming, we do want a gradual warming to develop. That would be ideal and preferred for a slow melt off of the mountain snow. So to sum things up, ENSO neutral conditions will likely to persist for the rest of the spring into the summer of 2020 and possibly into the autumn. The long range outlooks favor above normal temperatures and a drier trend for the Pacific Northwest late this spring or into this summer. And while water supply looks normal for the north, it lacks in the south. Drought conditions will likely persist as wildfire potential increases this summer. And that's all I have today. Thank you.
All right, thank you, Robin. All right, next we'll turn to Oriana Chapwin.
Hi, everyone. So thanks for inviting me to speak. I'm a research scientist and graduate student at the University of Washington, that I'm about to finish, so that's exciting. And I'm going to be describing today how you might be able to dive into greater depths about all of the things that Nick and Robin have showed you just now on your own using a website called the Climate Toolbox. So what is the Climate Toolbox? It's a free online website for inspecting climate and water data, along with agriculture and fire information. It's developed by a team in the University of Idaho and the University of Washington as part of the Climate Impacts Research Consortium. It's maintained by Catherine Hegewisch at the University of Idaho and Jonna Botzoglu there, and then Bart Nyson and myself at the University of Washington. University of Idaho, they handle the meteorological side of things along with agriculture and fire, and we handle the hydrology at the University of Washington. And Catherine really is a powerful force behind the Toolbox, and she's just a really driving force, and I wanted to highlight her leadership. So today, I'm going to highlight 3 main tools for inspecting historical conditions, but in particular future conditions across the Pacific Northwest, so that you can better understand droughts and variables that you might be interested in. So the 3 tools that I'm going to highlight are the Water Watcher, the Climate Mapper, and the Seasonal Forecast tools. And you actually might recognize some of the plots that that Nick showed in things that I'll be showing. I'm going to treat this kind of like a tutorial. So everything that I'm showing is screen captures from this tool. You'll be able to go there. I'll put the website back up on my last slide, but you'll be able to access everything I'm showing on your own. It's completely free and open. The figures that I'm showing now, I grabbed over the weekend, so they're essentially up to date, but there might be a little difference depending on when you go look at it. So tool number 1 is the Water Watcher. This is a tool for better understanding our current drought conditions and how we got here, along the lines of what Nick showed. So I want to highlight the classification across the top. So the color bar showing from exceptional wet to exceptional drought, from blue to red, is the way that you use to interpret all of the variables shown on the Water Watcher. Bluer means that it's much wetter than normal. Redder means that it's much drier than normal. Anything white means that it's about normal. Then each of these 4 panels in the middle are precipitation, snow water equivalent, then on the lower left, soil moisture, and on the lower right, stream flow. These are different variables that we've either produced ourselves or run ourselves or grabbed externally. I'll step through each of them now. In the upper left, I've selected precipitation. In this case, it's water year precipitation. As from the GridMet data set developed by Jana Botsoglu. So redder colors show that precipitation's been drier in Eastern Washington and Oregon. It's a little different from what Nick showed, just he was showing the last 2 months, but I'm showing the full water year. So we can kind of see how we got to where we are. In the upper right, it's snow water equivalent as modeled using the variable infiltration capacity model based upon the meteorological information from John and Catherine. And this is a gridded product in contrast to the SNOTEL products that Nick showed. So in the lower left, we see soil moisture conditions, and this is also a gridded product from modeled, and it's a way that you might be able to interact more readily with a higher resolution data product of showing soil moisture conditions, and that really confirms this lower than normal soil moisture conditions that we're seeing. And then in the lower right, this is stream flow gauges for the past 2 weeks from the USGS. So these are different variables that you can choose and kind of manipulate. There's a lot of different variables. And then in the upper right, you can compare it to the US Drought Monitor conditions. And then you can click on a specific location. In this case, I've selected a location right around Portland and compare what each of those drought metrics are for a specific location. And then the different kind of classifications of drought show up in the last panel in the lowest right panel. So we see severe drought according to precipitation. There's no snow there, so there's no bar plot for the snow water equivalent, but then soil moisture is moderate drought, stream flow is extreme drought for the stream that's nearest that location, and then severe drought according to the US Drought Monitor. So you can kind of use this to better understand what kinds of water availability are currently. If we want to dive a little deeper in though, we can see that we can switch to the Climate Mapper, which is the second tool. And this is one that you can use to look in greater depth about a specific variable. So here you can inspect in finer detail a single variable of interest that you select in the lower left panel, the far left panel, sorry. You can specify timeframes you want. For instance, current observations, you can choose just the first of the month. You can choose the water year since October 1st, and various increments like that. In this case, I've selected mean temperature anomaly in degrees Fahrenheit for the water year. And so we can see it's been relatively warm, except for these a few kind of cold, wet hot spots in the North Cascades and southeastern Idaho. That's really feeding those healthy snowpacks that Robin was talking about. But let's say we want to switch to looking at the future. So here, instead, you can choose from this drop-down menu, in the timescale option, the forecast selection. And so then we can switch to the ability to look at these forecasts that Robin mentioned as we're visualizing them in the toolbox. And in this case, I'm showing the mean temperature and precipitation anomalies for the next 2 weeks. These are downscaled by John and Catherine at the University of Idaho, and then put up here for users to interact with. And we can start to see this kind of relatively warmer conditions with some cooler conditions along the northern border with Canada, and then this wetting front that comes through in western Washington and Oregon for the next 2 weeks. If we want to take it further out, we can look at the seasonal forecast. So we also can choose seasonal, and this is the anomalies for May to July in temperature on the left and precipitation on the right. These are from that North American multi-model ensemble project that Robin mentioned. Okay, so then what we can do is also look at how this is going to impact hydrology. And yet again, this is a gridded product. And what we do is we take at the University of Washington, we take the temperature and precipitation information from John and Catherine at the University of Idaho, and we run it through a hydrologic model, and we see what the snow actually looks like in the gridded fashion. And so right now, this is what snow looks like in the Pacific Northwest. Like they were saying, we have pretty healthy snowpacks right now. And then what we do is we combine that current condition and with the forecasts that come out of the National Center for Environmental Prediction, and we take those forecasts, we combine it with the current states, and then we start running forward. So what I'm going to show you here is stepwise seeing the snowpack melt out going into the future according to our seasonal outlook. So I'll step through from 1 month for the next, I think I'll show 4 months. So right now, this is what the conditions look like. We'll jump to May. Anything white is about normal conditions for that time of year. Anything black indicates that there's no snow where there typically would be snow at that time of year. We can jump to June, and you can start to see this snow melt away. So by the end of by August, we're kind of seeing this snow fall away, and even those high conditions in the higher elevations are going to likely be gone according to our models. Soil moisture seasonal outlook. You can also compare soil moisture from now on the left, where we have these really low conditions compared to normal in April, and then some of that lower conditions by August. We're predicting that they'll be somewhat alleviated, but we will still see these lower conditions than normal in eastern Washington. One last tool is the seasonal forecast tool. So you're able to select for a specific location what these forecasts look like in temperature and precipitation going into the future. So we can dive deeper into these forecasts for a specific region of interest. In this case, I've selected a grid cell around Boise, Idaho. And looking at the temperature anomalies for that location, the mean that I was showing before in the map form is shown in the dark blue line across this plot. But the range in the full model ensemble is shown by the light blue band. And so you can use this to get a sense of ensemble spread. And this is just for the location specific to Boise, Idaho. Perhaps you want to care about a US county area. So this is Kittitas County in Washington. Precipitation percent of average for the next 6 months. And we're going to see kind of lower conditions, but of course there's less precipitation falling in the summer. So a low percentage doesn't necessarily mean a lot of water lost. But there's another way you can kind of look at these seasonal forecasts in terms of maps of different models or different months. And these are all static maps, but you're able to kind of see a progression through the season or deviations among different models. So these are these 3 key tools that I want to highlight: Water Watcher, Climate Mapper, and your seasonal forecast tools. And I'd really encourage you to try it out on your own. This is the URL, the link if you want to go to it for your own kind of interests or scientific questions or practice. And we really would love to hear from you if you're, depending on how you're using it, we'd love to hear from you. And then also a shameless plug, if any of you are interested in anything about climate change and hydrology, I'll be defending in a month, and it's a Zoom defense. So if you want to hear more about hydrology in the Northwest and climate change impacts, reach out and I can give you a link to that. Yeah, thanks so much.
All right, thanks, Oriana. We have just a couple minutes and there's a few questions for you, so we'll go ahead and take those right now. First question is, do all of these data that you've shown on the toolbox, do they cut off at the US border, or do they include the Canadian part of the Columbia Basin?
Right now, yeah, they are just in the US part of the basin. There's challenges with getting meteorology, like a seamless transition between the US and Canada. And so currently it is just in the Northwest, just in the US part of the Northwest.
All right, thanks. So the second question is, in the toolbox, how is the NMME-based seasonal forecast tool for soil moisture made? The NMME seasonal forecasts do not include soil moisture. Did you force some land surface model with the NMME forecast to produce soil moisture?
Yes, exactly. So, and that's one of the great things about the toolbox is that we take the meteorology from these forecasts and we run the variable infiltration capacity hydrology model, land surface model, using that information. It's entirely self-consistent, so you can look at what our kind of current estimates of what it's like in the Pacific Northwest is right now, and then we use those exact kind of what it looks like right now, and then we just apply the forecast to that and run it into the future. And you're able to see all of that. It's open and you could go look at it right now. But it's something that we do.
Sorry, say that last thing, Oriana.
It is something that we create ourselves. We don't take it from anyone else.
Great. Okay, so I think we will go ahead to our final speaker, and that is, we'll go over to Kelly.
Are you seeing my screen yet? Oh, you are, but I'm not. Okay, there we go. Okay, thanks very much for having me today. CMOR drought reports are a way for the general public or stakeholders to provide input to the U.S. Drought Monitor process, and of course also to provide information for state agencies and other people who make decisions based on dry and wet conditions. CMOR reports replace the old Drought Impact Reporter user reports. We're really taking advantage of recent technology. It's very slick. It's off the shelf. It's from Esri. We're using their Survey 123 and ArcGIS Online to collect and map observations. And in answer to questions we get a lot, it is mobile friendly and it accepts photos. The Drought Center works in partnerships with state agencies, university extension, and others that have a presence on the ground in a state who know the lay of the land to recruit participants and publicize the opportunity to potential networks of observers. We're not out in your backyard cultivating observations without a local presence. Some people do find it online and independently submit, but for the most part, we're working through state and regional networks. Consistency contributes to credibility, so we would like to have at least a core of regular observers over time. To help to provide some context, for the surges of event-driven reporting that inevitably happen as drought comes out in different places. So if you go to go.unl.edu/CMOR_drought, that's the landing page for CMOR drought reporting. The image you see on the left is the top of the survey form that people fill out, and on the right is the map where reports appear. And I'll go through each of those in a little bit more detail now. The first thing we ask people to do is tell us what area they're reporting on. And for all of the great technology that Esri brings to bear, it is a remarkably complex task. There are two different ways that the map widget allows people to report their location. The first is by using that compass icon, the circle with 4 ticks on the left, and enabling your phone or your device to provide its location. The other way is by typing the name of a place in the search box above. That also works really well, especially if somebody doesn't want to provide their exact address or their precise location of their land. They can type in a city or a county and the marker will be placed at the centroid of that geographic location. So that's helpful for some people to know. And finally, something that we've learned the hard way, don't scroll after you have placed the marker. Use the plus or minus button to zoom. If you scroll, it will kind of randomly move the map around and your marker will not appear in the place that you intended. After that, we have a quality control step. We ask people to select their state or island territory and then their county or a local district. This is a quality control step. It allows us to at least see whether the marker is in the correct state. It doesn't place the marker on the map though. We ask people to provide the date of their observation and then we use the time sensitive mapping feature. There's this slider bar at the bottom. People can expand or contract the interval of time shown by dragging on the left or the right marker. And there's a play button. And if you push that, then you can also push a pause button if you want to see how things progress over time. It goes down to as little as a week's worth of reports at one time. Currently, it's showing about 6 weeks worth of reports when it was particularly active in California and Southern Oregon. And I will mention, you can see that I've kind of messed with the zoom. I'm showing you different extents. I'm just kind of focusing on areas where reports are because at this point we don't have a whole lot of reports from the Pacific Northwest. The next thing it asks people to do is identify how dry or wet it is on this 7-point Likert scale. This is the same scale used by CoCoRa's observers. And people seem to really like it. It also provides us a way to have a common map layer with CoCoRa's reports. CoCoRa's observers are very well supported citizen scientists. They get a lot of training and wonderful communication, and we don't have that luxury right now. So we like to be able, we think that someday it will be useful to be able to compare what CoCoRa's observers and CMOR observers are saying about the same locations. The next set of questions puts observations in a U.S. Drought Monitor type of context. We ask people how long they've been in a particular spot, which also may give them a little bit of credibility in some people's eyes. And then we ask them how many times in the past they have seen it like that. So it kind of gets at, is this a 1 in 10 year? Is this a 1 in 20 year event? And then we, on the experience tab, we map those. The 20 or more years are squares, 10 to 20 years are diamonds, and 10 years or less are circles. Then people get into the impact checklists. At the left, you see the list of sectors. People can choose as many or as few sectors as they'd like to report within. There is one I'll mention related to spawning fish that may be of particular interest in the Pacific Northwest. If you click on the triangle, it expands the impacts from a sector into specific impacts. It displays all the impacts within a sector. This is what the top of the crop production impact sector looks like. If people check other down at the bottom, it pulls up a box where they can enter a description of what they're seeing. Then we map the impacts in several different ways. The overview tab is what I've been showing up to this point. It shows all of the impacts. then to the right of that, you see tabs for each of the different sectors where impacts have been reported. So this is showing what the crop sector tab looks like. This is all of the, or a section of impacts that are reported within the crop sector. And then if you click on this lower red circle area where it says see detail on crop related impacts, it takes you to another suite of maps that is specific within each sector. Within a few sectors, we have pulled out certain impacts have been identified as particularly of interest, and we can add to this collection of highlighted impacts. But for now, if you go to the crops sector, then we have a separate tab just for the reduced yield impact. So out of all of those different crop impacts, these are ones that have reported reduced yield. They may also report other ones, but they definitely are reporting reduced yield. In the livestock impacts, we're pulling out poor pasture conditions. Anyone who's reported poor pasture conditions would show up on this tab. And in the household impacts, we're pulling out any time that people have said that they have low or dry wells. People have the chance to upload up to 5 photos. We ask them for some caption related information to help us understand what they're seeing. Then we ask people for their name, organization, and email. We don't publish that information and we don't share that information. But it is helpful if, for example, we would like to use one of their photos in a publication. We can contact them, or we can contact them on someone else's behalf to request permission to use a photo or something like that. And so far, people have been pretty happy to have their photos shared. We also have this option, we're kind of pioneering this year, an identification code. It's come up that people in some places have said, boy, it'd be nice if we could contrast extension or expert observers with the crowd of crowdsourcing. So we've created this opportunity where I can give people an identification code, and if they enter that, then their report will display as square, as an expert drought observation rather than the usual round observation on the overview layer. And so far this isn't happening a lot, but it's early in the season. So if you would like to request the expert code, please email me and I'll be happy to provide it. I kind of want to keep track of who's doing what so that, yeah, I know what to look for and what not to look for. So if you drill into one of these dots on the map, you can see it looks almost like a speech bubble, a little arrow on the left pointing to the dot where it came from. Then it pulls up this summary of what people reported. In this case, the person is saying that you can see they've said they've been on that spot for 20 or more years. They've seen it like this twice or more in the past, most recently in 2011. And then where they've checked several impacts under livestock production, they show up in these kind of lowercase lists with underscores underneath the instead of spaces and commas. So that's what that means. When you see that kind of format, that means those are individual impacts that they've checked off. In this case, the person has also reported a low or dry well. And if you see this under attachments, if there is something like that looks like a link, that's if you click on that, you get to this, in this case, this photo of cows being fed hay in Northern California. So that's what I've got. There is a landing page where you can find the survey and the map. That's go.unl.edu/CMOR Drought. Then to get to the current year's survey form, it's CMOR Drought _2020. If you need the expert code, email me. And remember that consistency counts. You kind of want to get to know people, and you do. If people report over time, you get a feel for what their interests are. And those consistent observers are really helpful for calibrating when we get sort of a surge of event-driven reporting. So that's what I got. Thanks.
All right, thank you, Kelly. So now we have plenty of time for questions. So just a reminder, if you have a question to ask, please use the question box to type your question in. If you have your hand raised, it works better if you can instead type your question in. So that we can take those as they come. Okay, so I will do the first, there's a question for you, Kelly. Is the CMOR Drought Reporter a new name for the Drought Impact Reporter, or are they different?
The Drought Impact Reporter, as it currently is being added to, is just media reports. So this replaces what used to be the user reports in the Drought Impact Reporter. But because it is currently a completely different technological platform, it goes in on an Esri-based form into an Esri database, and it comes out on an Esri map. It displays separately. So currently the two processes are separate. Eventually we expect that there will be a way to display them on the same tool, but they are currently separate. And they are they're two different sources of data. One is crowdsourced and one is culled from the media.
All right, thanks. And the next question, I think this is either for Oriana or maybe also for Nick. The question is, when will the 1981 to 2010 normals be updated to include the years after 2010? For example, to compare, current SWE conditions.
Nick here, and I don't have specific information, but we obviously have to wait for 2020 to complete, and so it'll be sometime in 2021. And Oriana may actually remember what the latency is there, how long we have to wait, but it won't be in January. It'll be a while before those new climate normals will have been established and will be the baseline for everything.
Yeah, Nick knows better than me. So.
Okay, thank you. We also heard through chat from the Western Region Office of National Weather Service that the normals question is coming out in June 2021. Thank you, Andrea.
Okay. Thank you.
Okay, next question is for Robin. In general terms, how have the very high AO index values influenced our winter-spring climatic conditions? Aren't the values among the highest we've seen on record?
With that positive Arctic oscillation, what that tends to do is keep the jet stream confined further north and not allow much in the way of cold air moving into southward into the region. And we've kind of seen this last winter that we really didn't see many cold air outbreaks happening, more of a progressive pattern that we've seen. So that's one of the things that we've seen with more positive Arctic oscillation.
All right, thank you. Next question. Soil moisture map shown earlier shows substantial drought in lower Clearwater River Valley area of north central Idaho and the Idaho Palouse, yet the Drought Monitor has not picked this up as a drought classification. Why? I think that might be either for Oriana or Nick or Robin. Either one.
I think that's a great example of when, this is Oriana, when the Water Watcher is a great tool for being able to inspect things on your own. I think a lot of this information is sometimes, it's useful seeing a variety of different sources of information, and in the climate toolbox you can compare different measures, different indicators of drought. So you can look at maybe soil moisture, or what is stream flow looking like, or what is the U.S. Drought Monitor looking like. So whether or not the Drought Monitor has picked, like those maps have picked up on it, you can kind of go through and look at what variable interests you most.
I just wanted to add on to that. For that area of North Idaho, I think in Idaho they evaluate the drought monitor. Every couple of weeks, they're going to start picking it up now a little bit more frequently. But over the past several weeks, we have seen this progressive pattern with snow accumulating in the Panhandle Mountains. And I think that's what they're keying on right now, is the amount of snowpack that is available in the mountains.
Great, thank you. Oriana, we got a couple of questions for you. One is, are any of the products in the toolbox, do they account for soil moisture holding capacity?
Yeah, so the all of the soil moisture products are results of kind of total soil moisture in the variable in this hydrologic model that we use. So they account for kind of it accounts for the seasonal nature of soil moisture. Is that?
Yep, thank you. Another question is, let's see, where did that question go? Are state data sets and National Weather Station data sets used in the climate mapper or other tools on the toolbox?
Yeah, so there's an example that I showed was of the stream flow gauges. That's something from the USGS. It's not something that we do anything internally with. Catherine pulls that in directly from the USGS reporting. So there's kind of different variables we integrate into the toolbox so that you can compare them with things that we create at the University of Idaho and the University of Washington. So we do incorporate other external data sets.
Okay, another specific question, Oriana, for you. Is there any connection with soil layers that indicate soil depth and specific soil holding capacity?
So the only thing that we report right now is total column soil moisture. We also, the way that we report it is through kind of percentiles with respect to what the model has shown in the past. So we're never actually reporting actual moisture estimates. We only kind of we report what the model is saying currently exists in the total column compared to what it experienced in the past. But yeah, we don't provide any kind of like top layer, bottom layer, nothing like that. It's all total column.
All right, thanks, Oriana. There's a comment and a question here that snow water equivalent on the Olympic Peninsula is only available from snowtail sites on the Strait of Juan de Fuca and Hood Canal. What needs to happen to get snowtail station and or methodology developed to get more confident forecast for the west end of the Olympic Peninsula rivers, which are essential for all sorts of management decisions?
I'm not sure if that's a question. That's a kind of policy matter, and obviously there's cost involved with expanding the snowtail network, if I don't know who you would actually lobby for that, but it's true the Olympic Mountains do not have very good coverage, and especially on the western and southwestern flanks.
All right, another question. Oriana, are there plans to expand the climate toolbox to Alaska?
That's a great question for maybe John and Bart. I have not heard any, but I know that the climate toolbox is something that people are really enjoying, I guess if I do say so myself. But it's something that could, I mean, actually currently the spatial fields of meteorology are available CONUS for the full continental US. I'm just showing the Northwest because that's where the hydrology is available. But if you were interested in places outside the Northwest, it is currently available for the continental US. But Alaska specifically, I do not know.
All right. Well, we are at the top of the hour. Thank you to all the speakers, and thanks everybody for joining. If you have a question that you didn't get your answered, or you have some further follow-up, please feel free to reach out to the speakers directly, shown here on this slide. So that, again, the recording of this webinar will be available on drought.gov later this week, and the PDFs of the presentations can be accessed by emailing Britt Parker. Thanks again for joining. Please mark your calendars for the next webinar on June 22nd. All right, take care, everybody.